For these questions, you're going to model each problem with an open array. An open array is just a modeling strategy for division or multiplication, and it's made from rectangles or squares that are labeled. Let's look at some examples, starting with number 1, 3 times 7. Well, in a standard array for 3 times 7, you would see 7 columns of squares. So this side would be represented by 7. But you'd also see rows of squares. In this case, you would see 3 rows. So this side would be represented by the number 3. As those lines intersect, they would create all these other squares, and if we counted them up, we would find that there are 21. So 21 represents the total number that is made when you multiply 7 by 3. It's the product. So 7 is one of the factors, 3 is one of the factors, and 21 is the product. A regular array takes a while to make because you have to make all these lines and squares. So an open array is a more representative way of making it. So you can do it quickly. So for an open array, what you would think about is we have 7 columns and 3 rows, or it could be 3 columns and 7 rows. But either way, you're going to think that one side is going to be longer than the other, because one is going to be 7, the other is going to be 3. And then you close it up, and you've made your open array. You label the inside with the total number. So this is a standard array, and this is an open array. The lengths of your sides don't have to be exactly anything. You're just representing it. So you can just do the best you can on getting a good length. If you had 7 times 3, you wouldn't want to draw it like that because that's not representative at all, as one side being a lot longer than the other side. So that's all you want to be careful about when you're creating your open arrays. Okay, so for number 2, this time we have a division problem. But what I want you to really understand is that a division problem is just a multiplication problem, just rearranged in a different way. So the open array is going to look exactly the same for a division problem as it did for the multiplication problem. Remember, on 3 times 7, we had 21, and 21 was the largest value out of the 3 numbers. Well, in a division problem, the number that's going to be the largest value is the dividend. The other 2 numbers can be rewritten even as a multiplication problem to make seeing the open array easier. So in this case, we have 6 times 6, which equals 36. It's the same exact problem as 36 divided by 6 equals 6. So the arrays would look exactly the same either way. Another thing to notice about this problem is that 6 and 6 are the same number. So when you create an array for this, it's going to be a perfect square because the length is going to be exactly the same as the width. Inside of the array, you're going to label the product, the total number. You're going to label the product or the dividend. So let's look at number 3. This time we have 28 divided by 4. Since it's a division problem, we know that the dividend is going to be the greatest amount. So we know one length of our array is going to be 4. The other length we can figure out by doing the division. 28 divided by 4 is 7. So the other side is going to be 7. So if this is 4, then 7 is going to be longer than that. And then you can just close up your array, and you would label the inside with your dividend, or if you remade this into a multiplication problem, it would be your product. So let's do number 4. Here we have 72 divided by 8, which gives you 9 as your quotient. So to make your array, this one's going to be almost square because 9 and 8 are almost the same. So if that's 9, then 8's just going to be a little bit shorter. You're going to label, and inside you're going to write your dividend or your product. We'll skip number 5 and go to number 6. Here we have 8 times 8. So this time we have a multiplication problem. Your product is going to be 64. So when you draw this, you want to make sure that both of your sides are exactly 8 so that when you close it up, it makes a perfect square. And inside of your open array, you're going to label it with your product, 64. So I want you to notice that every one of these problems looks the same. Just by looking at one, let's say I create one that has a length 5 and a width of 4, which would give 20 altogether. You wouldn't know if I was modeling a multiplication problem or a division problem because they look exactly the same. So I could be modeling a multiplication problem, or I could be modeling a division problem. So if you're looking at an array, don't be confused on the division arrays. It's just a different way to think about a multiplication array. So you try some on your own, and if you need help, you can come back and rewatch the video. Good luck!